every time companies think that they're going to use AI and robotics to do something that has a social engagement to it, a social interaction component, they totally underestimate how hard it is. Because what they underestimate is all of the varieties of ways in which humans behave and how hard it is to accommodate for all of that. And social doesn't just mean robots that take care of people in nursing homes, say. It means self-driving cars, because driving is social. You're not just on a highway. If you were just on a highway, I mean, Mercedes has been doing that for 10 years, as well as Tesla. But if you're in an urban area, now you're dealing with strollers and kids and beach balls and dogs, and it's social. And that tail of the distribution where you have weirdo social interactions that are complicated and hard to predict, where somebody's trying to get in their car, the walker's in the way, but somebody's on the other side trying to cross the street and they're waving you on. And then they get annoyed when the car does not go when it's being waved on. That's completely social. And that's very, very hard to solve. So I see that being the place people end up failing. Another example of that is actually Watson. In healthcare, data analytics and research, yeah, that works great. But as soon as you say we're going to take actual patient medical records written by a doctor, often handwritten, and suck them all into a system that's supposed to do uniform AI on it, the problem is doctors aren't uniform. They're human beings. And so even the way in which they do diagnostics and express their diagnostic sentiments aren't the same. And so Watson at IBM was blown away to realize how much variability there was that made it too hard for their AI system to operate correctly. So often that's where you see people fall short of expectations when you're at that kind of that boundary between automation that you're hoping just kind of works automatically and the social messiness of human reality and human behavior. The places where, in fact, systems have done better than I ever imagined has to do with narrow examples of gameplay, where systems with deep learning have just managed to figure out techniques that blow away the people. Examples are Jeopardy, examples are Go. A really great example is poker. And nobody in my field could have imagined 10 years ago that the world champion at poker would be a robot. Because we thought poker was hypersocial, right? But the thing that's special about it is, in the case of online poker, it's not about facial expression. It's not about gestures anymore. And so the essence of poker that ends up being social is around bluffing and mental models of others. That part the robot can do better than the human. And we never imagined that. The part where I thought we'd have more leverage by now, and it's going, and it's very exciting, but we haven't quite got there yet, is in the area of exoskeletons. Mm-hmm. Electromechanical systems are interesting because when we talk about computation, just pure thinking, computers really do get better every few years. And it's kind of like we've created our own deadline for that. We've forced Intel into a corner where they have to make them faster and faster. And so they do. And AMD does too, and everybody else does. So computers get faster, which means our weather models get better. It means our air quality models get better. It means chess playing gets better, Go gets better. But when you get to electromechanical systems and battery chemistry, those don't get cornered by Moore's law. They don't double in speed every 18 months. Batteries get better every once in a while. Every 3 years, somebody has a discovery and goes, oh my God, lithium iron phosphate is amazing. So then you have suddenly a step function improvement. But you don't know when those discoveries are going to happen. Same thing with mechanical systems. You know, we introduce a new kind of harmonic drive and the exoskeletons get better. But we didn't know when we're going to get that new harmonic drive. It just happens when the mechanical engineers have a really big aha moment. So I've seen those systems improve and they continue to improve, but we can never quite predict when. And the dream I have, and the thing that we have to get to, is that those exoskeletal systems become game-changing for the elderly and for those who are paraplegic in our society to be able to walk with us and hike with us and enjoy the world with us. That applies to millions of people. But we haven't quite got there yet because they're not quite affordable yet. And even though the DoD has them, they cost millions of dollars each right now, and no insurance company can supply that and afford that. So that's been slower than I expected, but it's going. But anytime it's mechanical and electromechanical and battery-based, it's just going to be a slower game that we have to play. It's a longer game.